There are 4 different ways to change the rate of reaction: concentration, temperature, surface area, and catalysts. We'll be looking at catalysts in a different section. What you need to be able to do is draw graphs of increasing concentration, temperature, and surface area, and that effect on rate of reaction. Every graph you come across will look similar to this. They'll have a starting point at 0, so at 0 time there will be 0 products, and ending with a flat bit. This means that all of the reactants have been used up and there are no more products being formed. How quickly you get to this point, this line, depends on the rate of reaction. If you were to have a slow rate of reaction, the graph would look like this. Here, as you can see, it reaches the same level, the same amount of products formed, but it takes longer to get there. If we were to have a faster rate of reaction, it would look like this. The products are formed in a shorter amount of time and reach the end point, the end of reaction, much quicker. So for example, this one here is an extremely fast reaction. So if we were to have a look at this, in an exam you might easily be asked which of these has the fastest rate of reaction. So the first concentration here has a very low slope. It's a shallow gradient. The more shallow the gradient is, the lower the concentration, the slower the rate of reaction. So 1 has the lowest concentration. Therefore 3, because it has the steepest curve, is the fastest, which is the highest. Concentration. It's a very similar idea with surface area. So can you guess which one of these has the highest surface area? Which one is the powdered marble chip? Answer in 3, 2, 1. Hopefully you guessed correctly. Number 3, this one with the steepest slope, has the largest surface area, which is the powdered chip. So 1 is the smaller surface area, the large chips. And finally, temperature. Again, this is exactly the same. The steeper the graph, the faster it is. Therefore, number 3 is the hotter temperature. The examiners might try and trick you out with something like this though. They might turn around to you and say, which of these has the fastest rate of reaction? It would still be D. E is incorrect because the end reaction, provided you use the same amount of reactants, so the same amount of hydrochloric acid and marble chips, it will always finish at the same point. If you draw something higher, it means you have to have more of the reactants, so more of the marble chip and more of the hydrochloric acid. So to recap then, the end point of the reaction is where the curve becomes flat. Number 2, the faster the rate of reaction, the steeper the curve. Number 3, if the end point of the reaction ends up higher, it means you've changed the amount of reactants.